we have the form f of x equals ax squared plus bx plus c for a quadratic function. There's another form that's very useful, and that's called the vertex form. Let's take a look at that. Here we have the vertex form for a quadratic function. It's f of x equals a times the quantity x minus h squared plus k. This form has several advantages. First off, if we have a quadratic function in this form, we can read off immediately the vertex. The vertex is at h comma k. We can also talk about the shape of the parabola, and that's given by the a. For example, the parabola is narrower than our basic x squared parabola if the absolute value of a is greater than 1. The graph of the parabola is broader than x squared if the absolute value of a is between 0 and 1. Say a fraction, 1/2 or 1/4. We can also determine whether the parabola opens up or opens down based on the sign of a. A is positive, the parabola will open up, like x squared. If the a is negative, it will open down. All right, let's take a look at this form in an example. Here we have a quadratic function, f of x equals 2 times the quantity x minus 1 squared minus 3. We can immediately read off the vertex. This fits this form, a times x minus h squared plus k. So here we have minus 3, so we know k is negative 3, and the h is 1. So the vertex is going to be 1 comma negative 3. Now, in the form for the vertex, it is x minus h. And here we have x minus 1. And that's why the x coordinate of the vertex is 1 and not negative 1. Now, in the form for the vertex form, it's plus k. Here we have minus 3, so the y coordinate is negative 3. All right, so keep that in mind. All right, I'd like to go ahead and take this quadratic function and plot it as we've done before, and verify that the vertex is indeed at this 1, negative 3. So let's start out with x, and then we'll have our f of x. And we'll plug in some x values. All right, let's start off with, say, negative 2. All right, if we plug in x equals negative 2, we'll have negative 2 minus 1, which is negative 3. Negative 3 squared is 9. 9 times 2 is 18. Minus 3 is 15. Negative 1, we have negative 1 minus 1 is negative 2. Squared is 4. 4 times 2 is 8. Minus 3 is 5. X equals 0. Well, negative 1 squared is 1, times 2 is 2, minus 3 is negative 1. Move on to 1. 1 minus 1 is 0. 0 squared is 0. 0 times 2 is 0. So negative 3. Let's look at 2. 2 minus 1 is 1. 1 squared is 1. Times 2 is 2. 2 minus 3 is negative 1. 3. 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8, minus 3 is 5. We can kind of see the symmetry that's happening here. We have the point 1, negative 3. And as we move 1 unit both to the left and to the right, we get the same outputs. 0, negative 1, 2, negative 1, negative 1, 5, 3, 5. 4 then, we could expect to be 15. Let's verify that. So 4 minus 1 is 3. 3 squared is 9. 9 times 2 is 18. Minus 3 is indeed 15. All right, let's plot this. So 1, negative 3. 1, 1, 2, 3. We are vertex. 0, negative 1. 1, negative 1. Negative 1, 5. And 3, 5. All right, and then we'll connect this with a smooth curve. All right, we can see that 1, negative 3 looks like that is the vertex, and with the vertex form we verified that. The graph here is narrower than x squared, as x squared would look something like this, wider than our example. The axis of symmetry would run through the x-coordinate of the vertex. So the axis of symmetry, if we wanted to write it down, would be the line x equals 1. So through here. Oh, and we also know that since the a is 2, which is positive, the parabola will open up, and we see that reflected in the graph.